This is the first actual talk I've done sort of face-to-face since, I think, February 2020, so a little bit out of practice sort of thing. I think all my last talks have been done in the bedroom, I think, actually, with our kids running around and stuff. Yeah, it's great to be here in person. And again, thank you for the invite. So I am going to do a bit of an extended introduction and biography here, because one of the reasons that I've been invited here is because I was invited by Robin Nicholson, who was actually one of my sort of mentors when I did a work placement at GlaxoSmithKline in Ulverston nearly 20 years ago. So I've not met Robin since, although we have sort of loosely kept in contact. And I'd like just to focus on some of those experiences as well. But the focus of my talk is really on reducing research waste, the initiatives versus the reality. And I'll be talking about projects that have sort of been completed and the ongoing research that we've been working on in this particular field. So just an overview then. So as I said, I'm going to give an extended background and biography of where I sort of where I am now and where I sort of my background, where I came from, and what kind of things I've been doing in that time. I will focus on research waste in my field of research anyway. It's a very broad field, so I'm only really going to focus on a small area that I've been working on. I can give some examples of that. I'm going to talk about the initiatives to prevent research waste that we've been working on. But also for forum for discussion as well. I think some of these initiatives that we sort of developed in themselves may also be creating research waste. So I just want to sort of really focus on a few of those things, and I'd very much invite opinions on those towards the end of the presentation. So that's pretty much work that we've done to date. But I do also want to sort of briefly talk about some new research, some of the ugly stuff, which I think also contributes to research waste and perhaps more serious form of research waste than some of the examples we've been working on to date. And we had some interesting discussions with Alison about those as part of your group earlier on over lunch. So just going to start with the background then. So from an education perspective, I did an undergrad degree in applied statistics in 1998 to 2002. And then the third year of that degree, this is where I did my year's work placement at GSK in Ulverston, with Robin. It was an industrial placement, working on industrial statistics. So I think the important thing to say is that it was a really insightful year. I obviously didn't go into work into industry. I stayed in academia. I didn't do industrial statistics. I'm more on the sort of clinical methodological side of things. But I think just if there's any sort of early career researchers, it really was a positive experience. And I think the main message to take away from that year was really that drive that I wanted to do statistics as part of my career, and perhaps really empowered me really to note that, you know, in order to progress in statistics, you need to do a postgraduate degree in statistics, which I went on to do, and then an opportunity came to do a PhD in medical statistics, which I did at Lancaster University. And you'll find where I'm at in my role at the moment, but interestingly, my PhD was done in Lancaster on the statistical analysis of trauma care data, and actually as part of my role at Manchester now, so that unit is based in Manchester where that data came from, and I'm actually oversight of that particular group now, so it really sort of swings and roundabouts and how these things sort of come about, so that's really also quite interesting. So following my PhD in Lancaster, I went to the University of Liverpool, where I started off as a research associate. So that's where I met my wife at Liverpool University. So I was there for about 13 years. So I sort of progressed through the ranks as a research associate and then as a lecturer in biostatistics. And just of interest to the RSS group, during my time as a lecturer in biostatistics, I was actually chair of the RSS Merseyside group at the time. I also joined the main conference board for the RSS, so I organised a few of the sort of conferences, and I know that the next one is here in Aberdeen, which is great news to see. I then became a senior lecturer in 2014, and I was doing that for a few years, and then this opportunity came across to switch across, do that switch across that you should never do from Liverpool to Manchester, which I did. Opportunity to become professor in biostatistics. Wasn't really, well, I went for the opportunity really to do more things, and the opportunities have come thick and fast actually. I took over the centre lead for that group in 2020, about a month before we went to lockdown, so that was to the relief of the person who was doing that role previously. But I've kind of learned a lot from that experience, and as I've from last month, I have taken on the head of division roles and more sort of management leadership role within the university. And my football team is Manchester United, so I'm going to focus a little bit on Manchester United in this talk, as just to sort of give you a bit of an analogy to some of the things that I do on a research basis. And you probably see actually the timings are quite interesting now. My move from Liverpool to Manchester really came at the time when I really needed to get out of the Liverpool situation, because a real shift in the performance of the two teams at that point. And very happy to be at Liverpool when Manchester were doing well. And obviously we're not doing so well at the moment. Okay, so my main focus of this talk is actually going to focus on research waste. There isn't a lot of statistics in this talk, in fact, virtually none. So it's more of a health service research kind of talk. So hopefully that's not going to disappoint you too much. But what I will say is that a lot of the work that we've been doing, the statistical underpin behind this, I think is really important. So so there's a series of articles that are published in the Lancet on research waste, and really these the main sorts of findings that came from this can be represented in this particular diagram, and it talks about all the sort of wrongdoings and inefficiencies that happen in the sort of research process, right from the sort of left-hand side where we're really talking about actually asking the wrong questions in the first place, right through to actually the way that we report our findings when the study is done. And obviously in between, there's a lot to do with sort of conduct, the design, whether the study is sufficiently powered, etc. And lots of these sorts of things all contributing to this research waste. So I'm going to focus on really two of my main areas. The first really comes at the very end of the process. So when I was a research associate, really focusing on things like selective reporting of outcomes, and this really contributes to research waste. So this is really situations where researchers don't publish the results of findings for all the outcomes that they pre-specified in their protocol, and this can lead to inefficiencies, research waste, but also this can really impact bias in terms of biasing the results that can inform sort of policy, and I'll give some examples of that. And really, my next sort of step really went to the other side of the spectrum right at the beginning, and really this came about choosing the important outcomes to be measured. And actually, really, these two things work in hand, because actually choosing the right outcomes at the very beginning of the study can actually be a solution to this particular problem. Okay, and the main sort of finding from this Lancet series of papers was that it concluded that about tens of billions of dollars of investment in research are lost every year because of correctable problems or things that we could have done better before we'd actually conducted the actual study. So I'm going to use a footballing analogy to just introduce the selective reporting outcome. And obviously, we're talking about tens of billions of dollars here being wasted in research waste. As you know, I'm a Manchester United fan, and we did pretty well at some point in time, and we're a research-rich club. We're a money-wealthy club, and obviously we've tried to improve and make adjustments to our team to gain more success. And since we last won the Premiership under Sir Alex Ferguson's managerial spell, we've actually recruited all these people into our team, and we've actually spent. Minimize that. 323.7 million on these players, and actually it's made absolutely no difference in terms of the way we form. So if anybody's hanging around after this talk, if you can name all those players, I will buy you a pint. And I think this is an interesting sort of thing, actually. We talked about research waste, tens of billions. Just a football analogy here, wastage on players and not really having any impact on your team's performance. But I think as methodologists, we're competing for very small amounts of research funding and able to sort of try and address these issues of research waste. And I think that's something that really needs to sort of change. So I'm just going to stick with the footballing analogy just for one more slide, just to demonstrate this selective outcome reporting that I've been involved with. Okay, so I'm going to compare these two football teams, which is my team, Manchester United, against Liverpool, which is one of our most fiercest rivals. And I think there's lots of different outcomes that you could choose to compare the performance of the two teams. But the one I'm going to choose is the one that's probably most people sort of recognise as being the most important, and certainly the one that goes down in the history books. And that's the number of trophies that are won. So we'll consider the different types of trophy these two teams compete for as the main outcome. So these are all the trophies at some point in time these two teams could have competed for. So we start off with the domestic cups, the Premier League, the FA Cup and the League Cup, and then we have the European Cups, and some of these obviously are not still in existence, but for this purpose of this talk, we'll assume that they competed for them at the time this analysis was done. So, I'm going to show you some data here, and this is data that I found comparing the two teams on how many times these two teams have won each of these cups. So we don't need to do anything fancy statistically here. We can clearly see that Manchester United is by far the most superior football team. So we'll just move on from that then, shall we? Right, I just thought I'd add in Aberdeen's results here, actually. So you just think here, well, obviously these are the domestic cups, and I'm using the Scottish equivalent here. And actually, if we look at this data, actually, if we compare probably the most important cups, which are those competed for at the sort of domestic level, actually, we could probably also say that Aberdeen is probably better than Liverpool as well. And we can probably just move on and just forget about it. But what's actually gone on here? Well, it is actually the Sir Alex influence here. So what I didn't actually tell you is that the data that I've actually taken here from the start of the Premier League under Sir Alex's influence, and we can see that under his tenure that Manchester United did much better than they have done recently. And we'll all know now that Liverpool Football Club obviously have won the Premier League since then. So I guess the problem with this data is I wasn't really very transparent about the time period that this data was taken. But is there anything else that's missing here? Well, actually, there is actually, and I've been very selective in the actual outcomes that I chose. I did actually miss out one particular outcome or one particular trophy here, and that was the UEFA Cup. And I selectively chose not to present that because Liverpool had won this trophy, but we hadn't in this period. So I've been quite selective there, chosen not to report it because we've never won that particular cup. We've won it since under Jose Mourinho, but not obviously in the period under Sir Alex. So is there anything else there that might be a bit suspicious? Well, if you've got a forensic eye, you will know that this cup here, the European Super Cup, has actually competed between the two teams who won the Champions League and the UEFA Cup in the previous season. And we can see here that Liverpool actually won it twice. So therefore, if we did a very sort of forensic analysis of this, I've actually only represented one Champions League win for Liverpool. So really, it was very obvious that something was missing here from that. So, and it was actually this cup where they won the UEFA Cup, and obviously when they competed for the Super Cup, they actually won it twice. So that's all well and good. I mean, don't get me wrong, this is really important to some people. But what happens if this sort of things happens in the medical context? And here is an example of this. So this is looking at disease-modifying drugs for rheumatoid arthritis. And what this matrix, I'm just going to move this again.
If you minimize it, it might on the right top.
So what this is a matrix of important outcomes. It's actually a core outcome set, and I'll talk about that in a bit more detail in a moment. And these outcomes actually measure disease activity, how a patient might be feeling, and also a measure of damage. And these are clinical trials. And these are all a selection of the trials that have looked at investigating the efficacy of these DMARD drugs on rheumatoid arthritis. And where there's a tick, we can see where the trial actually measured the outcome, and the blank spaces are those that didn't measure the outcome. So we can see here there are gaps, quite a lot of gaps here. And this is really perhaps a missed opportunity to measure important outcomes that are both important to lots of stakeholder groups, not just clinicians, but also patients. And where we know that selective reporting has happened here is that there actually, within this particular field, there are actually composite measures that are used to look at efficacy that actually encompass this core outcome set. So even though we know that these trials didn't report on these outcomes, we know that they at least measured them. And in my opinion, this isn't both selective reporting, but also increases this problem of research waste. So we'll come back to the core outcome set in a moment. So I guess throughout my earlier days, we did a lot of research on this issue of selective reporting. And so a colleague of mine who's working in parallel with me time doing a qualitative piece of research actually interviewed trialists where we suspected outcome reporting bias might actually be a problem. So this is, I'll just leave that quote on there for a few minutes just so you can have a read of that. And you can very clearly see from this example that trialists were really excluding outcomes from their reports because they didn't think the results were important, or basically based on the statistical significance of those findings. And we found this is not unique. We found lots of examples of this sort of thing that happened. We also found things with looking at adverse events. So people had demonstrated efficacy. The adverse event profile wasn't that favourable, so they decided not to include any adverse event data. So that's the other sort of side and the spin of that. And yeah, there was lots of evidence of this. And generally what we found is that I think it was generally the lack of awareness. So the researchers, they weren't doing this purposely, they just didn't think there was anything wrong with what they were doing. So I think it was really lack of awareness that this problem can lead to biased results. So part of the study that I was involved in was looking at the empirical evidence for outcome reporting bias. So we did this review, and this review looked at collating together cohorts of studies that had basically looked at inception cohorts. So they'd followed trials right from inception, ethical approval, right up to final reporting. And across all these studies we identified, we found that there was results were more likely to be published if there was statistical significance, and that ranged an odds ratio of 2.2 to 4.7 across all the studies that we investigated. We found lots of discrepancies in the primary outcome that had been changed. It was newly introduced or omitted, so basically a change from what was reported compared to what was planned. And we also looked at the problem across an unselected cohort of Cochrane reviews, and as part of the Open study, we found that outcome reporting bias was suspected in at least one trial in over a third of Cochrane reviews. So it's quite a substantial problem that we're trying to address here. So what's the impact of outcome reporting bias? Well, this is looking at a funnel plot. It's often used in meta-analysis. So this is a hypothetical example. We can see where outcome reporting bias is not a problem. We get this funnel shaped, and we can see that the odds ratio is about 1.41 in that example. But if outcome reporting bias is present, so small study effects are missing, non-significant effects are missing, because they're not reported on the outcome, we can see it basically overestimates treatment effect. And while I don't talk about it here, we did actually develop some statistical methodology for trying to adjust for this particular problem in meta-analysis. And we see quite a few examples where the effect estimate has been overestimated because of suspicion of outcome reporting bias. And it's a similar sort of effect to what you would see with publication bias as well. So really, what I'm trying to say is that based on this based on what we found throughout this study, I don't think anything was ever necessarily purposely done by trialists or authors. They were generally unaware of this problem and the implications it may have on the evidence base for not reporting all the outcomes in their protocol, or only selectively reporting those that were statistically significant. So that really is a summary of the kind of work that we did at the very end of that Lancet series on research waste, looking at reporting. So I then went on to look at trying to find solutions to this problem. Say some were statistical, but they are really sort of adjustment methods at the very end of the process. So trying to adjust, review meta-analysis to try and correct for the problem of outcome reporting bias. Perhaps a much more elegant solution to the problem is trying to address it right at the beginning of the process. So actually choosing the right outcomes to measure at the very beginning that are important to all the relevant stakeholder groups, and making sure that these followed through and these were reported in the final final results to those studies that have been undertaken. So a core outcome set is basically an agreed standardized set of important outcomes that should be measured and reported that reflect a specific disease or a condition. And the importance of the core outcome sets is that you clearly define the scope. So are they for all interventions? Are they for particular interventions? Making sure they address a good balance of both the benefits and the harms. And I think one of the criticisms of core outcome sets is that we're trying to force researchers to measure a certain set of outcomes that they may not particularly agree with. That's not really what we're saying. We would like you to measure these outcomes as a minimum. And if you want to measure 100 other different outcomes because you think they're important, then you're free to do so. So what we're suggesting is not really a restriction on what you should be measuring, just an anticipation that you would measure this core outcome set. I think most core outcome sets to date are focused on effectiveness trials, but there's increasing need, and now sort of developers also trying to measure or develop core outcome sets for routine clinical practice. And there can be a lot of overlap between those things, but sometimes there can also be important differences. So, and a few slides ago, I talked about the rheumatoid arthritis core outcome sets, and you can see there are lots of gaps in the evidence, some certain outcomes in that core outcome set that are not being measured. So we looked to the rheumatoid arthritis is an interesting example because its core outcome set was developed in the mid-90s, so it's one of the first core outcome sets. So there's been plenty of studies that have been done since that, and we wanted to really look at the uptake of this core outcome set in rheumatoid arthritis by basically trying to systematically identify all trials that have been done in this particular condition and having a look to see if they'd actually measured the full core outcome set. And we can see that there's been quite a degree of success in rheumatoid arthritis. We can see that when we last did the evaluation around about 2020, actually over 80% of the trials in rheumatoid arthritis are now measuring this full core outcome set. So that's a real success story. I think important things that happened along the way, the core outcome set was first developed in 1994, as I said. But also the regulators, the FDA and the EMA also recommended and endorsed this core outcome set a little bit after the development. So there's always going to be a bit of a lag because obviously we're looking at published trials, so it takes some time from trials to start to actually hit the being published. So there's always going to be this little time lag. We can see since about 5 years after this core outcome set was developed, there's a really sharp uptake in this core outcome set. So that's a real success story, I think, the core outcome sets. However, what if COS or core outcome sets are not used? The amount of uptake of core outcome sets is relatively small. So of all the core outcome sets that are available, for this particular slide, I've said when we did this analysis of 337 core outcome sets, I would say it's close to about 450 to 500 as I speak. But only 5% of core outcome sets have actually had some uptake assessments. So that's really quite low. This was systematically reviewed. And of the 17 studies, or 5% of core outcome sets where there has been some uptake assessed. The uptake range from 0 to 82%. So the 82% is clearly the rheumatoid arthritis one. But we can see that sometimes core outcome sets have been developed and nobody is actually using them. So really sort of the focus or the forum discussion here is, what is the point of developing a core outcome set if nobody's going to use it? That in itself is creating or contributing to research waste. So I think there are a number of barriers here on why people are not using core outcome sets. One is lack of measures. I think when you develop a core outcome set, there are essentially two constructs that researchers need. It's not just what outcomes to measure, it's also how you measure them. So what instruments are you going to use to measure core outcome sets, the core outcome sets? And not much work has been done on that, so particularly by the core outcome set development community. There is another group that looks at instruments, but I'd say the vast majority of core outcome sets that have been developed to date do not talk about measures. So I think that's one area we need to focus on, and certainly on the core outcome set studies I'm involved in now, we do make some recommendations about measures that should be used based on an evaluation of what's already out there in terms of measures. I think the other one is stakeholder involvement. So some users may choose not to use core outcome sets because they didn't involve the relevant stakeholder groups. We recommend that you involve basically clinicians or people who have experience of treating the condition, researchers, and most importantly, patients as a minimum. And many of the early core outcome sets did not involve patient involvement. And that might be one reason why people don't use these core outcome sets, because they don't feel as though they're relevant to the actual patients. I talked a lot about awareness, and I do think that's a big problem. If you don't know about the core outcome set, you're not going to use it. And the COMET initiative based in Liverpool, they have basically a searchable database of all core outcome sets. So you can actually search for all the core outcome sets that have been developed, but again, it's actually sort of directing people to make them aware that that facility exists. And also the scope. We talked a bit about the scope, but again, there needs to be some sort of clarity. When should you be using this specific core outcome set? What particular population should you? What particular interventions, etc., etc. So I think there's a lot of work that needs to be done on this. So this is really one area for the part of the discussion is that we're developing core outcome sets. As part of the core outcome set development team, we need extra strategies to think about how we're going to get people to use them. So simply developing the core outcome set and publishing that core outcome set is probably not enough. So some other work that COMET initiative is doing is looking at core outcome set endorsements. So I think these are important groups that we need to target, particularly to ensure that uptake is increased. As I said, I think there's a large suspicion that the rheumatoid arthritis success is down to the regulatory authorities actually endorsing the core outcome set. But I think there's lots of other target groups as well that we need to sort of focus on to get them on board to make sure that people are using core outcome sets. And I know, for example, looking at trial funders, particularly the NIHR, there is some recommendations in their guidelines for people applying for trial funding that you should search the COMET database to see if there's a relevant core outcome set you should be using when you're developing your application for funding. But yeah, this is very much in its infancy, and I think these are areas that we need, or particular groups that we need to explore to make sure cost endorsement is increased. So we've talked about research waste in terms of mostly financial burden, and we actually wrote this editorial paper actually, and looking at the NHR portfolio, we found that actually 4.7 million is being used to develop 14 core outcome sets. So just enormous amount of money just to develop sets of outcomes that should be used in trials. That's quite a lot of money. So why do we think that is? Well, I think the cost of developing core outcome sets is highly variable. They do actually make excellent PhD projects for clinicians, but they can be quite time consuming and resource intensive in the sense that we've got a minimum set of standards that we've recommended for developing core outcome sets. And this can be quite timely to go through this process. So basically systematically reviewing all the outcomes that have been measured historically to potentially include in the core outcome set, conducting interviews with parents or patients to see what's important to those. It's all quite a timely sort of process. And the more time you spend on these things, the more money it actually costs. So here's a particular example of a set of core outcome sets in cancer surgery. So there are actually 5 core outcome sets that exist for 5 different cancer types: gastric, colorectal, prostate, I'm going to say that esophageal, and anyway, the point here is that there's actually what you see in looking at the consistencies of the outcomes that were selected within these core outcome sets is that they're all pretty much quite similar, and they all focus on something like survival, adverse events, and impacts on impacts of the surgery. So it's basically sort of quality of life. So I think actually we need to start thinking, again, this is part of the discussion, we need to start thinking about smarter ways that we can develop core outcome sets. We shouldn't be developing them just for the sake of developing them. And I think there's a much more elegant way to do this. There's gaps missing here. There's lots of cancer types that don't have a core outcome set yet. But I think taking this summary on board, we could probably develop a core outcome set more generically for cancer surgery. And these would be the sort of very top level relevant outcomes for cancer surgery. And this is a project we're hoping to embark on with a PhD student. And I think this would be a step towards sort of reducing the amount of research waste in actually developing core outcome sets. And as I said, if any of these, so we could basically focus on outcomes looking at surgery, adverse events, and these impacts. And if there's anything else that comes across as being important for the individual cancer types, these can also be measured by the researchers to say core outcome sets don't restrict what you can actually measure. So I think that's one way that we can sort of improve. And another project that I'm working on as part of an NHR global health unit is looking at a stillbirth cause in actually sub-Saharan Africa. So there are actually already 2 core outcome sets that exist in stillbirth. One is on stillbirth prevention, and one is on bereavement care following stillbirth. There are methodological gaps in these 2 particular projects. In fact, it's really quite an elephant in the room when you actually look at it. And the reason is that we really need to start thinking about achieving global consensus. One of the gaps in core outcome set is about stakeholder involvement from different settings within the world. And actually, very few participants from Africa have been included in core outcome set development, only 9%. And usually these are quite tokenistic in the sense that it's probably just one person that's been involved. So this is quite a limitation, I think, in the stillbirth cause, because the vast majority of stillbirths across the globe actually occur in these particular settings. So they may not actually, these stillbirth causes may not be relevant for that particular community because there are lots of other things that should be taken into consideration. And in fact, a recent review of the core outcome set studies reveals that no cause to date has actually been initiated from Africa. So this is where we got a bit of funding to do a little bit of research. So I'll just pick on one of those core outcome sets, the one on stillbirth prevention, and just demonstrate what they actually did. So they followed a very sort of standard structured way for developing core outcome sets. So they identified all possible outcomes. So they did a systematic review of outcomes. And they also interviewed some relevant parents, but they only interviewed parents based in Australia and in the UK, so only from high income settings. They didn't include anybody from low income settings. The next stage, then usually we have sort of a consensus type process where we ask the different stakeholder groups to rate their preference on each of the outcomes in terms of importance. And again, within this particular study, 129 participants took part in the Delphi process. Vast majority, 124 of those from high income settings, and only a small handful were from upper middle income settings, and only one from actually a low income country. So basically, when we do these consensus processes, the importance or the opinions of that person would have literally been evaporated when combined with the opinions of everybody else within that study. And then they tried to ratify the core outcome set at the end, and basically they, within that final exercise of deciding which core outcome sets to include, they didn't include anybody from a low income setting. It was just somebody who had experience with dealing with stillbirths in a low income setting. So they weren't specifically from there, they just had a little bit of experience. So again, the conclusion really is, given the stillbirth rates in low middle income settings, can this cause truly be considered a global cause? And my answer to that is probably no. So when we set out to do this piece of work, or when we applied for the funding, I think it's particularly important. As we said, from the evidence, involvement of low middle income settings and cost development was an evidence gap. Some of the barriers cited were lack of time, funding, infrastructure, and other obstacles. And prioritising objective setting exercise. A number one important topic in a recent methodological research priority setting exercise for low middle income testing was actually choice of outcomes. So we have a lot of impetus to try and resolve or do a little bit of research around this particular issue. And why we think it was really important, first of all, we got interest from a group of researchers in Manchester looking at global maternal newborn health outcomes, and I was invited to be part of this to look at this core outcome set issue. But also we thought that this would be a really good opportunity to sort of educate core outcome set developers on how they may include such participants in their studies moving forward. So that's really what we wanted to do here. So this is what we wanted to do. We already knew stillbirth core outcome sets exist. So we didn't want to replicate what they'd already done, because that would also contribute to research waste. So what we actually want to do here, we actually want to do a very sort of rapid approach of basically doing a small piece of top-up research in the low middle income setting to try and come up with a core outcome set which is both relevant to the high income setting and the also the low middle income setting. So essentially a meta core outcome set. And we've started this research. I can tell you that it's really quite difficult to do. We've got we have 8 countries in Africa involved, and we have 2 countries, well, India and Pakistan, so South Asia involved. I think the work that we need to do is relatively straightforward, but we're just at the stage of getting ethical approval. And it's really, really quite challenging. And to be honest, very different depending on which country you're actually applying to. I don't think there are necessarily any issues with the methods that we're using. I think it's more about the fact that we're including parents that have experienced a stillbirth, and that's kind of a little bit of the challenge. But we're getting there. We do have some approvals. So I just have to acknowledge the funders here for that particular project. Okay, the last bit. We talked a little about the good, so obviously my career progression is going quite well, that's quite good. The bad stuff is what we've just discussed, so I think it's this problem of outcome reporting bias, these solutions, I think those are good things. It's bad in the sense that people are doing these things, but they're not really aware of it, so I think we need to do a bit of work there. But now is the really ugly bit, and this is the stuff I've been talking to Alison about. So this is where people purposely fabricate data. And basically, Alison talked about all these examples I'm going to talk about, but these are really good examples of data fabrication. So one of the first sort of major studies that was done on this was looking at, was done by Jeff Carlisle, looking at false individual patient data on zombie randomized trials submitted to anaesthesia. And this is a really interesting read. So how often do people actually fabricate their data for trials or any study really? Well, it's really quite hard to know. But from this particular study, looking at trials submitted to anaesthesia for about a 3-year period, so the study author managed to get some IPD, individual participant data available, and they actually reanalyzed these trials data, and they actually found that about 44% contained false data, and about 26% they said were actually critically flawed as a result of what they call zombie. Zombie is critically flawed. So the real question is, actually, how do journals actually deal with this bit problem? How do they actually identify these sort of problematic sort of trials? And really, in a lot of cases, you really need to do a bit of forensic examination. And this really brings back to the slide I presented on the Man United slide, where I sort of showed you the data on that where if you'd done a forensic examination of the data, you could see that clearly fabricated some of the data based on knowing that Liverpool had actually won 2 Super Cups, but the rest of the data didn't demonstrate that. So what do we do? So here's another example. I can give you a bit more detail about this one. So this is, again, we talked about this over lunch, looking at vitamin K and the prevention of fractures. So again, this is another really good study. And this looked at a meta-analysis of 5 trials suggesting strong effect of vitamin K on hip fractures. So we can see there's a decent effect size there, and also that effect is statistically significant looking at the confidence interval. But actually 3 of the 5 studies included in this analysis were actually conducted by 1 investigator, and the actual plausibility of these trials was brought into question. So the sort of things that were looked at was the baseline balancing characteristics, the group sizes, the plausibility of the recruitment was unrealistic, and unusually low attrition and large treatment effects were found. And I think it's much more easy to identify problematic trials when we look at them at the sort of systematic review meta-analysis stage, where we're doing these sort of forest plots, and we can clearly see that some studies, stick out a mile compared to some of the other studies, and that might be sort of a reason for some investigation. And it turned out actually this particular author did admit to data fabrication, and after you remove those trials, there is still an effect, but we can clearly see that's now not statistically significant. And I think one of the biggest challenges with this type of research is that it's very difficult to get these studies retracted from the literature or from the sort of public domain. So therefore, these studies, even if these studies have been queried, they're going to continue to be used in systematic reviews. They're going to be continually used to inform future practice. So I think that's one of the other issues that we need to sort of try and address. So we wanted to do a bit of work around investigating this particular problem. And we've always really struggled to get funding for it. And the reason is because when we get peer review comments back, they always say, well, we don't think this is really a big problem at all. We want to spend our money on doing something else. But we actually have got funding now, and I will talk about the project. But I think one of the real impetuses for us getting that funding was actually all the research that was done during the pandemic, because we managed to establish quite a portfolio of research where we suspect the data had been sort of fabricated. And I think there was probably a real, I think during the pandemic, lots of people have been doing various sort of COVID-related research. And I think they always want to be the first to demonstrate something. So I think there's a lot of things that have been done, shortcuts and just a general good practice research principles. And some people, I think, clearly fabricated some of the data. And this is an example of that. This particular drug got a lot of publicity during the pandemic. As we can see there, got 2.6 million views in this particular set of research, ranked 7 to 20 million articles of a similar age in terms of citations and basically metrics of views. And this really sort of went forward for a while, and then a more sort of forensic investigation took place into all these claims. I also work as one of the BMJ editors. There was a lot of editorials that were published on these findings and criticising them. And effects, essentially, the data were obtained, and it was basically summarised that a lot of this had been fabricated. A lot of copying and pasting of blocks of data in a spreadsheet, and it now appears that a substantial portion of this evidence of these claims of this particular drug being effective for COVID-19 was probably not true. And again, lots of work was done, so there's lots of things, but again, this issue of retraction, I think, is probably quite damaging. So these are actually, these are actually real examples. I can't say which studies they were, but this is examples of fabricated data. So we can see in both these examples, we can see evidence of basically data that's been copied and sort of pasted. So we get these very sort of repetitive patterns of data, again, that would be seen to be implausible in reality. We want to try and address this problem, and I guess the issue is that we can identify this more easily, I think, from the systematic review angle. In order to prove some of these things, we often need the individual participant data, which we know is not always easily available. But there are other sort of techniques that we can use, looking at just basic trial manuscripts, much more difficult to detect, but if you're a bit more forensic about it, you know, basically recruitment rates are too good to be true, baseline imbalance is perfect, for example, you might raise some queries. And this is really what we want to do with this particular project. So we tried many times to get funding, we did get it in the end. A colleague of mine, Jack Wilkinson, is going to be working on this. And really what we want to try and do is to identify all the methods that have been used to date to sort of detect fabricated data. We're going to start off focusing by clinical trials, but we also may want to expand later to different types of study. When we want to sort of evaluate the impact and the feasibility of applying those techniques to various particular studies through systematic reviews, and ultimately to try and develop a sort of checklist so that systematic reviewers can use them to sort of detect potentially fabricated results and make some recommendations on those. We've got quite a bit of stakeholder buy-in, so not just academics, also sort of publishers and journal editors in this particular process who might be interested. And yeah, that's really where we're at this stage. So we want to do this through a sort of consensus approach. So we don't want to be targeting particular individuals who we think who might have fabricated data. It's just about identifying them, how we address that particular problem, the systematic review process. And I think that's probably the first step, pretty much the same way that we would do for the look at things like risk of bias. And again, just need to acknowledge the funders for that. It's quite interesting because we actually got this funding through the Research for Patient Benefit Programme, which is perhaps an unusual way to get the funding for methodological research, but we actually put a really nice sort of spin on this from the patient perspective. We got a team together, and they were really horrified that sort of conclusions on practice were being made from sort of potentially fabricated data. So we managed to get the funding through this stream, which is unusual, but just to make you aware that they do fund methods research. So that really brings me to the end of the talk. As I said, I did want this to be a forum for discussion. There's plenty of queries, and I'm more than welcome to have that discussion with you. So thanks for listening. It's great to be in Scotland today, and I am going with the team afterward to watch Scotland versus Ukraine. So really excited. I think probably the only place to be who's going to support in Scotland, maybe.